Hello everyone, let's solve GATE paper CS1 2025 question 64. The maximum value of x such that the edge between the nodes B and C is included in every every minimum spanning tree in the given graph is. So this question actually requires the knowledge of MST. We need the maximum value of x such that BC should be included in every possible MST of the particular graph. So let's understand some prerequisites. What is MST? MST of a connected graph is a spanning tree. It means it connects all the possible nodes with a minimum total edge weight and no cycle. Okay. Graph may have multiple MSTs if multiple edge sets of the total same weight. The goal is to include the least weight edges while maintaining the connectivity and avoiding any cycle. Kruskal algorithm is one of the possible popular methods to find MST. We sort all the edges by increasing weight and add the smallest edges that do not form the cycle, and we keep repeating until all the nodes are connected. It ensures that all the smallest weight edge is included in any cut that connected two components. What is an edge in every MST? This is a critical edge. A edge in every MST if an edge is in every single MST if it is a unique minimum weight edge crossing the cut, means it is separating the graph into two groups where the edge connects them. If we did not connect that edge, then the graph will separate into two different groups. If there is any other MST with equal total weight that excludes this edge, then it is not in every MST. If there is any other MST with equal total weight that excludes this edge, then it is not in every MST. To force the inclusion of a particular edge in every single MST, prevent the formation of that MST which doesn't exclude that particular edge, and that can happen when all the alternative ways are more expensive. Okay. So for the given graph setup, you can see that we are given AB as 7, BC as X, CD as 8, AC as 1, and I think is it DB as 1, I think, and AC as 3. BD as 1 and DC as 3. Okay. But CD is 8 basically. The goal is to find the maximum value of that x such that the edge BC is included in every single minimum spanning tree. So let's understand that. Alternative path from B to C. So B to D and D to C. If I go by weight, then the total weight will be uh, BD का 1 है and DC का 3 है. तो 1 plus 3, 4. Total weight 4. So if x is greater than equal to 4, Kruskal could prefer BD and DC to connect B and C without BC, possibly forming a valid MST without BC. Okay. We want to force the inclusion of BC in every single MST. हमें ये forcefully कराना है. ठीक है. So if x is less than 4, then edge BC is cheaper to get picked by Kruskal. ठीक है. If x is equal to 4, then both the options are equal. So MST with or without BC may exist. But if x is greater than 4, then Kruskal will prefer BD to DC and it might be excluded. But the question is specifically asking maximum value of h such that a BC is included in every MST. Critical insight here is that to guarantee that BC is present in every MST, no MST should be able to replace it with other edges without increasing the total cost. If we want to ensure that BC is included in every single MST, then no MST should be like this, that no MST should be able to replace it with other edge without increasing the total cost. Okay. So if this is clear, then the reasoning will be if I put x as 6, अगर मैं x को 6 की तरह डालूं, then MST will be BD of 1, DC of 3, weight 3, and AD is 6. Okay. And it will exclude BC. It will exclude BC. So total comes out to be 10. Okay. Total comes out to be 10. So if I draw it, what I'm saying, BD, DC, and AD. So this is what the tree will look like. So it is connected. BD is 1, DC is 3, and AC is like AD is 6. So you can see that in this particular thing, BC is not forced. BC is not forced. So that is not like another MST is also possible. That BD is 1, DC is 3, and BC I can take. So it excludes AD. So total is again 10. So two different MST, BC is not forced. I want to force the inclusion of BC. So if I put X as 5, if I put X as 5, if I put X as 5, then MST will be BD with value 1, DC with value 3, and BC with value 5. Total weight comes out to be 9. So let's see what I'm saying. BD with value 1, DC with value 3, and BC with value 5. But here comes the problem. You can see that it starts having a cycle here then. So that is the problem. Like that is the problem. We want no cycle inclusion or whatever you call. Okay. So this is one such problem which we can get while solving this question. So what should we do? अब हम करें क्या? अब हमें क्या करना चाहिए? So let's talk about another. So if this is A, let's put it B, and let's put this C, and let's put it D. If I put connect A and C, that was 3. If I connect BC, then it is X initially. I will try to replace it. Another MST I can think is this 1. So 1 plus 3, 4, 4 plus 5, 9. So BD, AC, and BC. BD, AC, and BC. This particular thing, if I put X as 5, uh, at most 5, then the maximum value of X can be 5. If I put, then the total weight comes out to be 9. If I put X as 6, you can see that there is MST without BC as well. So for X as 4, if I put X as 4, then also this is the minimum one. If I put X as 3, so I want to find the maximum value of X. So I started putting X as 1. So it is a hit trial question. Put X as 1 and check the minimum ones. Then put X as 2, X as 3. When you reach as X as 6, there are the question ensure that ask that I have to include VC in every single MST. So the moment I put X as 6, what happens is that particular MST may not have VC, as you see in one of the examples. Hence, the maximum value of X that can has to be here is 5. So the answer is 5. That's it for this particular video. Take care. Bye bye. See you guys in the next video.